Here in Brazil, we have a group called Mathematics and Disaster Risk Reduction in the Brazilian Applied Mathematics Society. We are now thinking about internationalization with the group Mathematics of Planet Earth from Imperial College and the University of Reading.
agronomist by training, so I was graduate in the University of São Paulo, dealing with basic agriculture production, and but that has evolved a lot into more of an ecosystem sort of a study, interactions among different components of the ecosystem, and today I work basic on this, how human and ecosystems and how human and land use are influenced by each other in terms of water production, agriculture production, biodiversity, and ecosystem service in a broader way. Well, I think it's pretty central in a way that how you can deal with about a broad aspect of the disaster itself. From the physics, the disaster is associated to people that are impacted by that, and how actually those tools and the mathematics you see as a science can better predict or better calculate the strength of the disaster, the risk of that. And if we go a little bit beyond, how we can avoid a disaster becoming a disaster, how we can understand a natural occurrence of a changing in the landscape by a landslide, by a flood, which are natural aspects, but that cannot become a disaster in terms of affecting people. So I think mathematics, it's a whole science, not only a science, but a philosophy in terms of how you deal with those sort of, what tools you can choose, what sort of uncertainty you associated to this, and what sort of solutions you can drive or derive from this suite of tools and science. Well, first, as a learner, I'm not a mathematician, I'm not a modeler, but I'm very interested in those connections that I'm talking about. So this is a huge motivation. That's a personal motivation, an institution motivation, and as being coordinator of the Earth System Science Center at INPE, I think we need to bring this information and to connect the different activities that are going on in the center and the different efforts to understand the system in an integrative way. We need to be not only exposed, but we need to learn, and we need to connect people that do know those tools and those not only tools and not being simplistic, but knows the science, and by that know the science, the mathematics science, better in constructing the tools that will help to understand the system. So I think institutionally has a big motivation, and the person also, as I said. Well, on the first day we had 2 great talks thus far. But no, I think the group of people that are here, it's great, it's pretty broad. I think the international flavor of this is very important. I think the opportunity that comes forward, the follow-up opportunities associated to the funding itself, associated to building a collaborative project, I think it seems to be already there. So thus far, that's good. So far, so good.
Okay. I was trained in differential geometry and also in dynamical systems when I was a student. And throughout my career, I was all the time talking with applied people, trying to find out joint adventures, to work together in something that I could help the research. So I've done work together with people in astronomy, in robotics, and more recently, people in biology. Always using a little bit of differential geometry and differential equations, especially on little toy models that could give an idea of the phenomenon. Of course, dynamical systems classically has been very much used in epidemiology. Now, for risk reduction, there's a lot of modern statistics, which is beyond the old statistics which was fragmentist. Now for Bayesian statistics, there are many ideas that come from differential geometry. And there's a trend now to even use those techniques in the field of metrology. So no, I believe that differential geometry will help also this new area that is emerging of the mathematical tools for risk reduction on disasters. Okay, at this time of my career, which is towards the end, I enjoy being together young people that I can learn from and also tell a little bit of my experience, and also trying to lure them into some of the ideas that I have, but I don't have enough energy to do alone or by myself. This event is organized and done by young people, and I feel like I am enjoying very much to see and enjoy novel work that will have a big impact in the future. And I really admire this young generation of not only the Brazilians, but their counterparts in England and Uruguay that came together here to share ideas and make a networking for future work.
Right. My line of research is evolutionary biology. So I work with building trees that show the ancestry between living beings. And we apply these trees to human viruses and understanding human disease spread and maintenance. That's what I do. Well, there are many applications of mathematics in climate science, and of course this is related to disasters. But in my line of work, we also employ a lot of mathematics. So we employ discrete mathematics, combinatorics and graph theory. We do a lot of statistics and stochastic processes as well. So I think mathematics is crucial for us to have a quantitative understanding of disasters and also make informed decisions. Well, I think there's been a very good vibe up to this point, and my expectation is to learn what other people are doing and also build connections that we can take for our careers, and also build collaboration networks to strengthen the trade of technology and knowledge.
Right, so my field of research is complex systems and data analysis. Complex systems would be any system that involves many subsystems interacting dynamically, and in a certain way this defines a network, meaning that the subsystems interact among each other, interchanging information, and so you can say basically that they are connected. So basically any system that has many features, such as the weather, for instance, oceans, atmosphere, soil, humidity, many features, you can cast it as a complex system. Then that would be my research field. Well, I'm not a mathematician per se, I'm a physicist, but in that sense I use mathematics quite a lot. And mathematics has tremendous effects over not only on climate change and natural disasters, but also to be a tool in order to forecast. And that's a very important topic, being able to forecast and produce mitigation in case the forecasting fails, and so on. So modeling also to understand the systems behind and the reason behind any kind of emerging behavior. 2 years ago I was here in São Paulo for another of these kind of workshops, not related to climate, but actually to smart cities, I would say. And the interdisciplinary that involved there caught my attention. It was one of the most engaging conferences I have ever been people from all different backgrounds were here, similar to what is happening now, and this brought up very horizontal solutions to problems that usually if you are too focused in one particular expertise, you miss out. So this drove me here. I think my expectation after that one is quite high, and I think it will be fulfilled. I mean, so far what I have talked to each other and with my peers, it's going to produce some really nice results. I hope that from here on we can develop collaborative projects between Brazil, Uruguay and the UK. So far it's been great, especially because I could escape the cold winter in Uruguay. Here winter looks like summer.